Welcome to the second lecture on fractions, and we won't waste a lot of time on the intro, so let's just jump in. The first thing we look at for this video is simplifying fractions. And simplifying a fraction means finding an equivalent fraction with a smaller numerator and denominator. If the numerator and denominator are as small as possible, then the fraction is said to be in its simplest form. For example, 18 over 24 can be simplified so that the denominator and the numerator are written in smaller terms. We can write 18 as a product of 6 and 3, and 24 we can write as a product of 6 and 4. Since 6 is a common term in the numerator and the denominator, then we can cancel or factor out the 6, which leaves us with 3 over 4, which cannot be reduced anymore because there are no other common factors between 3 and 4. Therefore, we say that 18 over 24 and 3 over 4 are equivalent fractions, where 3 over 4 is the fraction in its simplest form. Second example, 8 over 16. Well, 8 is a common factor of 8 and 16, so we can write the denominator of 16 as 8 multiplied by 2. We factor out the 8 since it's a common factor in the numerator and denominator, and so we're left with 1 over 2. Therefore, 8 and 16 and a half, or 1 over 2, are equivalent fractions. But do you think we can find some more equivalent fractions for 8 over 16? If you said yes, then you are correct. If we take 8 over 16, for example, we can write our numerator as 2 multiplied by 4, because 8 is a product of 2 and 4. And we can write our denominator as 2 multiplied by 8, which allows us to factor out the 2. So we're left with 4 over 8, which is another equivalent fraction of 8 over 16 and a half. We can also take 4 over 8 and factor out another 2 from the fraction, as 4 divided by 2 leaves us with 2, and 8 divided by 2 leaves us with 4. So 2 over 4 is also an equivalent fraction. And just to show that 8 over 16, 4 over 8, 2 over 4, and 1 over 2 are equivalent fractions, let me just do a quick diagrammatic representation of, let's say, 4 over 8, 2 over 4, and a half. First, let's draw up the 3 different pies, one divided into 8 parts, another into 4 parts, and a third into 2 parts. Now, for the one with 8 parts, we shade 4 parts for the first pie so that we get the fraction 4 over 8, and 2 out of 4 for the second pie, giving us the fraction 2 over 4. And 1 piece is shaded for the third pie, which is the fraction a half. And upon examining these 3 pies, we see that the area shaded of the entire pie is exactly a half among all 3 pies. And so that's why they're equivalent fractions. Next, we look at operations on fractions. The first operations we look at is addition and subtraction. And in order for fractions to be added or subtracted, they must have the same denominator. For example, let's say we have 2 over 3 plus 1 over 6. We can't just add numerators and denominators. That doesn't work. So let's just put a big fat X through that. If we want to add 2 over 3 and 1 over 6, the first thing we have to do is to make the denominators of the fractions we're adding the same. In this case, we have the denominators 3 and 6 from the fractions 2 over 3 and 1 over 6. So we have to convert at least one of the fractions so that they both have the same denominators. So essentially, we're trying to find a common denominator for both the denominators 3 and 6. So how about the denominator that is the lowest common multiple of both 3 and 6? Right? That would make a lot of sense. In this case, it would be 6, since the LCM of 3 and 6 is 6. And if you need a refresher on LCMs, it will be linked above from a previous video. Okay. So since one fraction already has a denominator of 6, we need to manipulate the fraction with the denominator of 3 by finding an equivalent fraction for the fraction 2 over 3 so that this new fraction has a denominator of 6. So let's think. We have the fraction 2/3 and we want an equivalent fraction to 2/3 so that this new fraction has a denominator of 6. So what can we do with the denominator 3 so that it becomes 6? Well, we can multiply this 3 by 2. However, if we multiply the denominator by 2, we also have to do the same to the numerator, as this preserves the equivalency. So essentially, we're doing the opposite of simplifying in this case. This means that the new denominator is 2 multiplied by 2, which is 4. So our equivalent fraction for 2/3 is 4 over 6. Now we can finally add 4 over 6 and 1/6 since they have the same denominator. And when adding fractions, we only add the numerators together and we keep the same denominators. So our answer is 5 over 6. Again, we can show why that's the case. Let's draw up 2 pies, both divided into 6 pieces. We have 4 pieces shaded for the fraction 4 over 6 and 1 shaded for the fraction 1 over 6. When we add both of these, we end up with 5 shaded parts of the pie, so our answer is 5 over 6. Second example, 7 over 8 minus a half. Again, the first thing we have to do is make the denominators the same. In this case, we have the denominators 8 and 2. The common denominator that we'll use comes from the LCM of 2 and 8, which is 8. So we can retain the fraction 7 over 8 since it already has a necessary denominator, but we need to find an equivalent fraction for the fraction 1 over 2 such that this new fraction has a denominator of 8. So what can we do to the denominator 2 so that it becomes 8? Well, we can multiply that 2 by 4, but if we do that to the denominator, we also have to do the same thing to the numerator, which means that our new numerator would be 1 multiplied by 4, which is 4. And so the equivalent fraction to a half, which is with the denominator of 8, is 4 over 8. Okay, so now we can finally subtract. 7 over 8 minus 4 over 8. Again, we subtract our numerators and keep the denominator, so the answer is 3 over 8. Third example, 12 and a half plus 5 and 3 over 7. So now we're dealing with mixed numbers, and there are 2 ways to really handle this. The first way deals with handling the addition of the mixed numbers as mixed numbers. And what this entails is just, first, we add the whole numbers and then we add the fractions. So if we look at the whole numbers first, we have 12 and 15, the sum of which is 17. Next, we'll deal with the addition of the fractions, which are a half and 3 over 7. However, we have to follow the same rules of adding fractions, and so we have to make sure the denominators are the same. But right now, our denominators are 2 and 7, and so we need to find a common denominator to use, which comes from the LCM of 2 and 7. The LCM of 2 and 7 is 14, which means that we need to find an equivalent fraction for a half such that its new denominator is 14. In this case, 2 multiplied by 7 gives 14, so we need to multiply the numerator by 7 as well, which gives the equivalent fraction of 7 over 14. But we also need to find an equivalent fraction for 3 over 7 so that its new denominator is 14. We can convert 7 to 14 by multiplying by 2, and so we have to do the same thing to the numerator. This gives a new equivalent fraction, 6 over 14. Now we're able to add 7 over 14 plus 6 over 14, which gives 13 over 14. Our final answer is now the result of the addition of the whole numbers, 17, and the result of the addition of the fractions, 13 over 14. So our answer is 17 and 13 over 14. The second way we could have handled the addition of these mixed numbers is by first converting them to improper fractions. Now in the last video, I showed you all how to convert improper fractions to mixed numbers. Now, in order to convert mixed numbers to improper fractions, we just do the opposite. So to convert our first fraction, 12.5, to an improper fraction, we multiply our denominator by our whole number, so 12 multiplied by 2, and then we add our numerator, so plus 1, and we retain our denominator, 2. This means that the improper fraction is 25 over 2. We do the same thing with our other mixed number, 5 and 3/7. We multiply our denominator by the whole number, so 5 multiplied by 7, and we add the numerator, plus 3, all over the denominator, 7, which gives us the improper fraction, 38 over 7. And you can always check if this is correct by seeing if you get the same mixed number when you convert back. Okay, so now we're adding the improper fractions, 25 over 2 and 38 over 7. Following the rules of fractions, you have to make sure that the denominators are the same when adding. And right now we have the denominators 2 and 7. So we need to find a common denominator between them. This is where, again, the LCM comes into play. This is 14. And so we need to convert the fraction 25 over 2 to an equivalent fraction with the denominator of 14. To convert the denominator 2 to 14, we multiply it by 7. But we need to do the same thing to the numerator. And so our new fraction is 175 over 14. Following the same process, we find an equivalent fraction for 38 over 7 with a denominator of 14. In this case, it is 76 over 14. Next, we add 175 over 14 and 76 over 14. And we get 251 over 14, which we can then convert back to a mixed number. And this gives 17 and 13 over 14, which is exactly what we got in the first time doing this. So our last example, 6 and 1/4 minus 1 and 1/8. Again, the first way we can do this is by handling it as a mixed number, which means subtracting our whole numbers first. So 6 minus 1 is equal to 5. And next we subtract our fractions, 1/4 minus 1/8. But we have to make sure our denominators are the same. The LCM of 4 and 8 is 8. So we only have to find an equivalent fraction for 1/4 with a denominator of 8. We convert 4 to 8 by multiplying by 2 and do the same for the numerator. So our new fraction is 1/8. Now we subtract 2/8 minus 1/8, and that gives us 1/8. The answer is now 5, the result of subtracting the whole numbers, which was 5, and the result of subtracting the fractions, which was 1/8. So the answer is 5 and 1/8. Again, we could do the same thing by just converting everything to improper fractions. So if we fast forward a little bit, we get our improper fractions to be 25 over 4 and 9 over 8. And in order to subtract, we first need to make the denominators the same. Then let's fast forward a little bit because already you should be comfortable with doing this since we've done so many examples. The fractions that we end up getting are 50 over 8 minus 9 over 8. And the answer for this is 41 over 8. And as a mixed number, this is 5 and 1/8. Okay, I know this video was a little bit on the longer side, but I just wanted to do as many examples as possible so that you could get familiar with adding and subtracting a wide range of fractions, regardless of how they might appear. So in the next video, we'll be looking at multiplying and dividing fractions. So don't forget to subscribe and turn on the post notifications so that you won't miss it when we post. Like this video and share with your friends if you feel so inclined. And I'll see you in the next one.